So the idea is to look at two intermodal chains which do exactly the same thing. They bring the box from origin to final destination, but they use different logistic pathways. We also just learned that the maritime chains connecting the main ports in the delta do not differ, as they yield exactly the same profit level to the shipping line, unless volumes would be different. And who decides which port to use to ship his cargo and therefore can influence the volume potential of the port? Well, that is the shipper. Therefore, we will take in this part the perspective of the shipper. As the shipper's need is to transport the box from origin to final destination, the shipper will take immediately the door-to-door perspective. He will look at the available transport options, including alternative routings. Obviously, he will search for the solution with the lowest cost, but at the same time, transport solutions will need to match the minimum service level requirements, which act as constraints on the selection process. Investigating the shipper's perspective, I started by exploring the supply side conditions. For this purpose, I gathered quotes from different logistics service providers in the Delta, allowing compiling a number of representative case studies. Each case presents the alternative options next to each other, as illustrated here. We can truck the box, but also can use barge or rail, and we can do this via Antwerp or Rotterdam. The different options have been quantified in terms of their performances in cost, transit time, frequency of the inland service, as well as the environmental impact, which I have measured by means of the CO2 emitted. The objective is to better understand how shippers decide between the different chain options, and in particular, when we have two competing chains which do exactly the same thing as they are using the same transport mode. They only use different routes, different ports. So, in the case of two alternative chains using barge as inland transport mode, we can take out truck and rail. We now just have to ask the shipper which option he will choose. As a matter of fact, we will offer the shipper the possibility to spread his shipments between the different options. He can choose to send all his cargo through port 1, but he also can decide to send, for example, 60% through Antwerp and the remaining 40% through Rotterdam. Such an approach is what we call a choice-based experiment. Importantly, my choice-based experiment has been built on the cases, ensuring alignment with reality. My choice-based experiment included in total 16 choice tasks. 32 shippers participated, yielding in total 512 stated choices, which we can now analyze. In a first test, we will investigate how shippers trade off cost against differences in environmental impact. Note that the latter are relatively small, as we are always using the same modes for both options. Choice task 2 presents such a trade-off, where chain 1 is the lowest in cost and chain 2 is the lowest in CO2 emissions. All other parameters are held equal. The mean of the shipper's stated choices allocates around 70% of their shipments to chain 1, the lowest in cost. But before we can reach solid solutions about the shipper's choice behavior, we also need to offer the opposite situation, where chain 2 is the lowest in cost and where chain 1 is the lowest in emissions. Indeed, the stated choice behavior appears to be mirrored. Contrasting the stated preferences of the choice tasks allowed me quantifying the main effect, as all other factors are held constant. The minor cost differences are leading in the decision, but note also that shippers did not put all their eggs in one basket. We will now proceed by expanding with differences in frequency levels. In a second test, we will include the recorded stated choices from choice tasks with different frequency levels. The starting point is the orange line from previous experiment with no variation in frequency. Adding the other choice tasks which do differ in frequency, we find that the marginal means show that the less costly chain loses in preference when the more costly chain offers superior frequency levels. However, enhancing the service level in terms of frequency of the lowest cost option has no impact at all. So the conclusion that can be reached is that enhancing the frequency level only helps the more costly chain. And also note that cost remains the driving decision factor. Let's move to a third test. In the initial choice tasks, I did not inform the shippers about the port. I just referred to chain 1 with port 1 and chain 2 with port 2. However, the same choice tasks are presented to the shipper, telling him now that chain 1 is Antwerp and chain 2 is Rotterdam. Would this change his choices? The initial means for the different frequency levels are displayed. Adding the names of the ports shows that the means of the similar anonymous choice tasks are exactly the same. In other words, shippers did not change their choices when port names are disclosed. The port system is not differentiating at all. In addition to the 3 tests which I showed, I also carried out a number of tests where I changed the situational variables. For example, I included choice tests which just changed the trade direction from import to export. The choice behavior was not affected. I also asked the shippers if their choices would be different when assuming another trade lane than the Far East. Also here the answer was negative. Choices of the shippers are clearly driven by the performance of the chain and not by the situational variables. Let's now conclude by postulating the theorem of the delta in the delta, building on the findings from the empirical analysis. First, the starting point that we need to take is the entire chain, which is only as strong as its weakest link. Second, when looking at the ocean transport systems connecting port with port, we find that they are not differentiating as they yield the same profit to the shipping line. This conclusion is reached under the important assumption that both ports offer the same volume potential, resulting into call sizes and vessel load factors which are the same. If one of the ports can offer a larger volume potential, it will attract more liner services, as shipping lines can leverage their profitability. Liners will therefore tend to follow the volumes when deciding on the port of call. So, the volume potential drives the ocean carrier port selection. Taking now the perspective of the shipper, We find, interestingly, that shippers do not care at all if their cargo is shipped through Rotterdam or Antwerp. Summing up these findings, we can answer now the research question, which is, what is the role of intermodal land transportation? Well, intermodal barge and rail systems connecting the hinterland and the delta ports are not just there to make our environment more green, but they can be used as fishing rods to attract more hinterland volume, which on their turn are the bait to catch the big ocean carriers. Intermodal transport solutions can make the difference in competing door-to-door chains. They are the delta in the delta. Thank you for showing interest in my research, and I hope you enjoyed the presentation.